Hi everyone, welcome to our last lesson in 5.5. This is part 3 that we're doing today, and it's the last 2 pages of our 5.5 notes. So we're in part 3, and I'm going to ask you to have your Z-score table handy. So if you don't have it out, take a moment and pause this, get out your Z-score table in your yellow data booklet so that you can refer to it because we're going to use it today. Okay, let's go ahead and get started. We're going to look at 2 different topics in this last lesson, and the first topic is how to determine the area between 2 z-scores. So up to now we've looked at how to figure out, if we know a z-score, to find the area to the left of that z-score. And we can also find the area to the right of it if we say 100% minus the area to the left. But now we're going to find out how to figure out, if we have 2 z-scores, what percentage of the data falls in between the 2 z-scores. So let's go ahead and do this example. We have z is equal to 0.25 and another z-score, z is equal to 1.57. Well, I could think about where those might live on a standard curve. So on a graph or on a standard normal distribution curve, where the center of my curve is given a value of 0 because it's 0 standard deviations away from the mean. And as I go to the right, I go up by 1 standard deviation. And as I go to the left, I'm going down by 1 standard deviation each time. Okay, well, z is equal to 0.25 would live between 0 and 1 on my curve. So it's a positive value above 0, but it's not equal to 1. It's not that great of a value. So it's approximately a quarter of the way. Okay, a quarter of the way between 0 and 1. So it would be right here. Z is equal to 0.25. There's one z-score. The other z-score I have here is z is equal to 1.57. Well, 1.57 is just past the halfway mark between 1 and 2. So 1.57 would be right around here. So I can put those on my table to give me a picture of what I'm looking at. And then I could use my z-score table to figure out what percentage of the data is to the left of each z-score. Okay, so if I go ahead and figure out what percentage of the data is to the left of the first z-score, z is equal to 0.25. Remember how we look that up on our table? Okay, we look up the first 2 digits, the 0.2. Okay, we look down the column under Z until we see 0.2, and we look across for the last decimal place, which in this case is going to be a 5. And we look across the rows and we locate 0.05. Then we take our fingers and we come together and see where do those 2 values meet on the table. Well, let's see, they meet at 0.5987. Perfect. If I wanted to figure out what that value is as a percentage, I multiply it by 100%. So I take 0.5987 and I times it by 100%, and that's going to give me 59.87% of my data is to the left of this z-score, 0.25. So 59% of the data would be this shaded area right here. Okay, so from here to the end of my curve represents 59.87%. Great. Let's do the same thing for the green or other z-score, 1.57. So again, I look up the first 2 digits, 1.5. I look down, and I look at the last digit, which is 0.07. I look up on the top across for 0.07 in the top row, and I come and I find where they meet. So I come to the center of my table and I see that they meet at 0.9418. As a percentage, that's going to be 0.9418 times 100% gives me 94.18%. Great. So that tells me that 94.18% of the data lies to the left of my z-score 1.57. In other words, all of this data to the left of it represents, so from here to the end of my curve is 94.18%. All right, what I'm really looking for then right now is this area that I'm shading in blue between those two z-scores. If you have a look at that for a minute, you already know the area to the left of the green line, and you know the area to the left of the red line. So we don't care about the area to the left of the red line. We want to just know this in-between area. This area right here is going to be the difference. Okay, it's the difference between the z-scores, and it's the difference between the areas to the left of each z-score. So I'm going to take the larger percentage, which is 94.18, which is to the left of the green line, and I'm going to subtract all of this red area over here. I'm going to subtract that, which is 59.87, and that will just leave me with the blue area between them. So it's going to be the difference. It's going to be 94.18% subtract 59.87%. I'm going to find the difference by doing that subtraction. On your, you can do this down below, okay, on your notes. I'm just going to write for ourselves quickly how to do this then. Okay, we've just done it, but I'll just write it out clearly for us as well. So let me just add a page to our notes. Okay, great. All right, so to find the area in between z-scores, you can write this at the bottom of your page. So to find the area in between z-scores, okay, we subtract, or we take the difference in areas. So we find the difference in areas. And remember that the areas here are just the percentages. That's what we're finding, percent of data, which is equivalent to our area. So we're going to say the percent of data then in between. Okay, between z-scores, in this case, is going to be equal to 94.18% minus the smaller area, 59.87%. And my answer is going to be 34.13%. That is the area between those two z-scores. 34% of the data lies within those two z-scores. Great. So I think now we've covered how to find the area to the left of a z-score, to the right of a z-score, and now even in between two different z-scores. Let's carry on and look at the very last topic that we're going to deal with in statistics, and that is, if I know the percentage of area to the left of a z-score, can I work backwards and figure out the z-score? And it's very easy to do. So we've already used our z-score table to figure out if I know a z-score. I look in the center of the table and I find the area under the curve, and I then multiply it by 100%. We can also work backwards. If we know that percentage of area to the left, we can use it, find it in the center of the table, and look to the left and up to the top to figure out what is the z-score. So we're just literally working backwards in our table. Let's do an example. Here's our question. What z-score is required if 10% of the data is to the left of the z-score? All right. Well, thinking about that for a minute, if this is your standard curve, okay, 10% of the data is to the left. That means that's not a lot of data. 10% is a tenth of all the data, so it's a pretty small fraction. So I'm not exactly sure where that might be, but I'm guessing my z-score might be around here, because 10% of the data is a pretty small fraction of the data that's to the left of it. Okay, so I'm expecting my z-score to be negative, and maybe somewhere between 1 and 2, I'm not sure. Okay, I don't expect you to know how to estimate that, but we know that it's going to be a very small fraction of the data. Okay, so let's go ahead and figure out exactly what the z-score is. 10% of the data can be written as a decimal. I want to look it up in my center of my table, and in the center of my table, they're not percentages, they're all fractions. So they've all been divided by 100%. So we're going to do the same thing. We're going to take that 10% here, let's divide it by 100 or 100% to get it as a decimal so I can look it up in my table. So 10 divided by 100 is 0.10. And again, I could add another 0 or even 2 zeros to it if I wanted to, because I see that in my z-score table, the percentages in the center, or the areas in the center, are usually to 4 decimal places. So what I'm going to do is I'm going to look up in the center this value. So I'm going to try to find a value that is very close to 0.100 in the center of my z-score table. So we're going to look in the center of the table for the closest value that I can find to this. So I'm looking for 0.100 in the center of my table. We may not find that exact value, but let's see how close we can get. So take a moment, have a look in your z-score table. We're searching for it. The closest value that we can find is going to be 0.1003. That's the closest value that I can find to my value here, 0.100. So, well, that's pretty darn close, and so that will give me a pretty accurate z-score. So now what I'm going to do is I'm going to put my finger on that value, and I'm going to look to the left. Okay, so I'm going to look across to the left to get the first 2 digits of my z-score. And so the first 2 digits of my z-score are going to be negative 1.2. And I'm also going to look up to get that very last digit, which is 0.08. Okay, and so my z-score is going to be negative 1.28. There's my z-score. So that tells me that 10% of the data is below a z-score of 1.28. And so I am 1.28 standard deviations below the mean. This is how we do it every time. We're looking for the percent of data to the left. Okay, we change it to a decimal, and we're looking for the closest value that we can find. Sometimes you can't find the exact value, and sometimes you find 2 values that are close, and if that happens, we're going to take the average of those 2 z-scores. Let me show you what I mean. Let's do another example. What z-score is required if 25% of the data is to the left of the score? Okay, again, same procedure. I'm going to go to the center of my table, and I'm going to look to the left and up to find my z-score. But first I have to change 25% into a decimal. So I divide it by 100, which gives me 0.250. And again, I could add another 0 there. Okay, and I'm looking for this in my table. So we go to the center of the table, and we look this up in our table. And I'm trying to find an area that's really close to 0.250. You will look around for this for a while, and what you'll find is that you see 2 values that are close. So in this case, the closest values are 0.2483. So there's one value that's a little bit below it, okay, and the other value is a little bit above it, 0.2514. Before you immediately go with 0.2514 or 0.2483, have a look at those 2 values and ask yourself, where does 0.2500 lie? It's approximately halfway in between them. 0.2483 is only about 0.2 or 0.0017 below the value that I want, and this upper limit right here is 0.0014 above the value that I want. So my value is almost halfway in between those. So what I'm going to do if that happens, if the value you want is halfway in between two values on your table, you're just going to take the average of those two z-scores. So the z-score for the first value here, the lower value, if I look to the left and I look up, I see that z is equal to negative 0.68. And for the upper z, or the upper area, the higher number, if I look to the left and I look up, I get a z-score of negative 0.67. So I have two z-scores. I know my actual z-score lies right in between those two. So what we're going to do is take an average of those. Let me just go ahead to a nice clean sheet here and continue writing. Okay, so since 0.2500, okay, is in between these two values, and it's pretty much halfway between. These two values. If this situation happens, we take the average z-score for those two values. So we figure out the two z-scores and we average them. So our z-scores, our average z-score here is going to be negative 0.68, okay, plus the other one, negative 0.67 divided by 2. Okay, or you could even look at it and just say, well, what's halfway in between them? It's going to be equal to negative 0.675 will be halfway in between those two z-scores. Okay, and so that's going to be our value for z. So z is equal to negative 0.675. We won't round this one up because we've actually gone to the work to say it's a little bit higher, yeah, a little bit higher than negative 0.68. So, and it's not quite as far as 0.67, negative 0.67. So we're going to leave that little 5 there to show it's halfway in between. Okay. Let's do one more together, and I'll let you try some of these by yourself. Okay, so our last question, what z-score is required if 15% of the data is to the right of the z-score? Be a little bit careful with the wording. 15% of the data is to the right. Okay, well that's not what our table uses. Our table shows us data to the left. So we need to be careful that we don't immediately go right ahead and look up 0.015 on our table because that's going to give us the wrong z-score. So just bear that in mind. The percentage of data, okay, to the left will be 100% minus 15%. Let me just draw you a quick curve just to show you what I'm talking about here. So what it's saying to us is that 15% of the data is to the right. So we don't know where a z-score is, but we know this. 15%, you know, might look something like this, okay? Small fraction of the data is to the right. So 15% is to the right of my z-score. Well, remember that the total area under your curve represents 100% of your data. So this shaded area to the left, which is what you want to look up on your z-score table, is simply going to be 100% minus 15. Okay, so 100 minus 15 is going to give us 85%. So 85% is to the left of the z-score. And that's what we need to look up on our table. So 85% is to the left. Okay, great. So now we can go ahead and look that up on our table. Remember, your table only reports areas to the left of a z-score. So let's change 85 into a decimal. So we'll divide it by 100 and get 0.85. Okay, and then we're going to look this up in our table, in the center of our table. And we're looking for the closest value. And again, if we find a value that's close, we'll use it. If we can't find a close value, we can find two values, then we'll have to take the average. But in this case, we see there is a value on our table. It's 0.8508. Okay, you'll see that on the positive Z-score page if you're looking through your Z-scores. And that's pretty close to 0.85. Okay, or 0.8500. Really, really close. So we'll use this one. Okay, and let's figure out what is the Z-score for that. So I look to the left to get my first two digits, it's 1.0, and I look up to the top and I see that the very last digit is 4, the second decimal place is 4, and that's my answer. So a Z-score of 1.04 will have 85% of the data to the left and 15% of the data to the right. I'd like you to do a little bit of practice with these questions. So I've assigned you in your textbook questions 3, 4, 8, 9, and 11 on page 264. At this point, you can also start your Chapter 5 review and get yourself ready for our test on statistics. Thanks for joining me and good luck. Bye for now.